Okay, in this lesson we're going to talk about compound angle formulas, and we are going to cover both cosine and sine. Normally we would do those on separate days. We're going to do them together. We're going to skip the development of the formulas in order to speed things up. In a normal year, we would spend a lot of time developing these formulas, and there's some really interesting ideas in it. The development of this first one is got some interesting stuff, and then using it, what we do is we use it to develop all of the others, and that's also all very interesting, and there's a lot of neat kinds of tricks or math concepts that we just don't see very often. So it's really good to do, but we don't have the time, so we're going to skip that. So we are going to condense these two lessons into one, but it's gonna be shorter because we're gonna skip a big part of each lesson. That being said, I will make videos from previous years available that have the full development of each of the formulas if you would like to watch those. Again, it's a good idea to see these kinds of things if you're going to be taking any kind of math heavy subject in university. You will probably be seeing more and more math like this, so having seen some of it already is helpful, but we're going to skip past it. Often we not only teach these, but we even do have them on tests and expect students to be able to recreate the development of the formulas, but we're not going to do that this year. So we're in this lesson, we're just going to talk about how to use all the formulas for sine and for cosine. The completed version will also be available in the scanned version of the lessons online if you want to look at it. So I'm just going to quickly scroll through it. You can see this one's fairly long. It looks complicated. It's really not that bad. It's pretty doable. Okay. And what I'm going to do before we get to using them is I'm just going to switch over to show the completed version of the four formulas that we're going to use. You can see two of them are cosine, two of them are sine. We call these compound angle formulas because it is the sum or difference of two angles. It's a formula that is used to find the cosine of two angles, A and B, if you're adding them or subtracting them. And what you notice is it takes the sum or difference of two angles and turns it into the formula is just cos of A and cos of B, and then also sine A and sine B. So the formulas are useful in that they take a sum, right, and turn it into something that isn't a sum. And that's what we're going to be using. That's the benefit that we're going to get out of this. In the types of questions that we are going to explore. And then we'll eventually get to identities as well with this, and it's the same thing with the identities. We can take something that's more complex and turn it into something that's, I suppose, easier to work with in many cases, that sort of thing. So we'll see that when we get to it. But these are the formulas, so you probably want to pause the video and write these down right now. You need to memorize these. They can be there's pros and cons here. They're very similar. And so once you sort of have a couple of them memorized, that can be helpful in memorizing the others. But the con is that because they're similar, I think maybe some people also get them mixed up. So you do have to make sure you know which ones are cos and which ones are sine. The way I remember them is I suppose I remember them in order. So we always start with the cosine ones, and the cosine ones are both cos, sine, sine. Right, so the coses are together and the sines are together, compared to the sine formulas where it's sine and cos and sine, or sine and cos. So that's one of the ways that I think that I keep them separate. And then the other thing that I think is helpful to remember is when it's cos together. So I'm not switching up the ratios because it's cos, sine, sine, but I do switch up the signs. So when it's cos of A minus B, I'm adding, and when it's cos of A plus B, I'm subtracting. And then I compare that to the sine formulas where I'm switching the ratios. So it's sine, cos, cosine, but I don't switch the sign. I hope that makes sense. However you think of it, you do in the end have to have these memorized. And generally speaking, that's not a tricky thing. I know it seems like a lot of formulas to memorize all at once. We're going to add a couple of tan formulas, so it feels like a lot, but I don't find that students have a hard time memorizing them. Generally speaking, if you do the practice, you will have these memorized by the time you're kind of done the practice. Okay. So that's the four formulas that we need right now that we're going to start out with, and we really are going to focus on one particular use of them. There's a couple of different kinds of questions in the homework, but the main one that we're going to focus on is how to find the exact value. Notice it says determine the exact value of some new angles. So we've never done the exact value of an angle of 15 degrees before. We're going to do one in degrees because I think it sort of helps. Again, we've done this in the past to make sense of what's happening. But after this first one done in degrees, we're going to do all the rest in radians. Okay. So ultimately, you need to be able to do this in radians. What we notice is that in the past, in degrees, we could do cos of 30, cos of 45, cos of 60, and any multiple of those. But we've never done the exact value of cos of 15, right? And so that's what we're adding in, the ability to find the exact value of multiples of 15 degrees when we have these compound angle formulas, okay? And the reason this works is because the compound angle formulas take the sum or difference of two angles and turn it into single angles. So think about this. What I'm going to do, my first step is we're always going to think of things in terms of 30 degrees, 45 degrees, and 60 degrees, right? Those are our three angles that we can already do the exact value of. And if I can come up with a sum or difference of those angles that gives me the angle I'm looking for, in this case it's 15, then I'm going to be able to use the formulas to find that exact value. So if we start with 30, 45, and 60, I have to come up with a sum or a difference between those three that gives me 15. And this is why it's, I think, useful to start in degrees, because I think it's pretty obvious, right? You've got two options. 45 minus 30 is 15, or 60 minus 45 is 15. So let's do cos of 45 minus 30. So we all agree that 45 minus 30 is 15. So this expression is the same as cos of 15. But then what I can do is I can use the formula. Cos 45. Remember, the cos formula is cos, sine, sine, but the sign flips. So cos 45, cos 30, plus sine 45, sine 30. Right? So I've used the formula, and now we see why this formula is useful is because I can find the exact value of each of those four ratios. So I've turned cos 15 into something into an expression that's in terms of ratios that I know how to find the exact value of. Okay, and so now I'm just going to go ahead and evaluate each of these and then sort of simplify it, and then we'll be done. So cos 45, again, this is using the special triangles. I talked about this before. This is where, in this course, if you haven't already memorized the value of these, you probably will if you go through all this practice. We're doing 4 of these in each question, so you really do just start to memorize the values of these. So cos 45 is 1 over root 2. Cos 30 is root 3 over 2. Sine 45 again is 1 over root 2. And sine 30 is 1/2. And if you don't have those memorized, then you're using the special triangles, you're drawing out the special triangle, and you're doing the whole work for each of those. Those are all quadrant 1 angles. So, in this case, it's a little bit easier. For these questions, they won't always be quadrant 1 angles, but in this case, they are. But like I say, it really does pay. You do have to think about the quadrants, because if you're in quadrant 2 or 3 or 4, you might have negative values, but to come up with the actual value, it really does help speed things up when you have them memorized. And in this one question, we have all of the different options, right? You have either 1 over root 2, root 3 over 2, or 1/2. For these questions, those really are the only options that you have. And so we see them over and over and over and over and over again, and eventually, even without trying, you'll probably find that you have them memorized. So now doing the fraction math, this works out to root 3 over 2 root 2 plus 1 over 2 root 2, which is root 3 plus 1 over 2 root 2. And again, as you're going through the practice, you will see that all of these questions have a very similar form in their final answer. They all kind of look like this. They're not all exactly the same, but they're very similar. And so if you do all of the practice and all of the review and everything, and you really prep this, you will know what the answer should look like, and that's a nice check at the end that you've done it correctly. You do have to absolutely show all of these steps. You can't just punch this into your calculator and give the final answer. You need to show everything. Your calculator won't give you the answer quite in this form, and this is the form that I want to see. So you have to know how to do this on your own, but you could check it with your calculator. Okay, that is definitely something that you could do. You could use your calculator to check. Like I said, it's not going to look like that when you type it into your calculator. Some calculators will give an exact value in a fraction form, but it won't look like this. So in this case, it would look like root 6 plus root 2 over 4, I believe, is what the calculator would give you. So, that's not an acceptable answer for a test. But what I would just do is I would just look at the decimal version and make sure it's the same. So look at the decimal version of this and punch cos of 15 into your calculator and look at that decimal version and make sure that there's the same. Or the other thing that I do sometimes, this is a good trick, is I would write out cos on my calculator minus, and then do the fraction, root 3 plus 1 over 2 root 2, right? I would type that into my calculator, and if they're the same, then you should get 0. And that's a nice check that what you've done is correct. So that's a good way to use your calculator to check, but you do have to show those steps. Now we need to look at it in radians, and this is where it does certainly get trickier. And so there's another level of complexity when we're dealing in radians, but the steps are the same. You're always breaking up your angle into the sum or difference of 2 other angles, and they have to be 2 angles that we can find the exact value of. So they're always going to be multiples of 30, 45, or 60. Then that's step 1. Then you're using the formula to expand it out. That's step 2. And then step 3 is evaluating all of them. And then step 4 is simplifying after you've evaluated each of the individual 4 ratios. So that process never changes. It's the same thing every single time, and that's why, again, a lot of students have success with this, because it is a step-by-step process, and you're doing the same thing over and over and over again. That being said, there is an added level of complexity and difficulty when we're dealing with radians, so that's the last sort of piece of the puzzle for doing these questions that you want to focus on, and we'll talk about that and do a few examples, but that's definitely something that many of you will be spending some time thinking about and sort of understanding, coming to understand that part of the process of these questions. And if you have questions about that, as always, email me, come into the chats that we have throughout the day, and we'll talk about it. We'll figure it out. Very often, students have questions about this process, and so that makes sense that it might take a little bit of time for you to get to it. So let's see what that process is. Let's get into it. So the reason why it's harder, one of the reasons why it's harder in radians, is because pi by 12 is not, it's just not a number that we're familiar with. It's the same thing when we were graphing, and we would often convert things back to degrees to think about the relationships, because we understand common factors, common multiples in degrees, better than in radians, because radians are fractions and it's just not something, and they're written in terms of pi very often, and it's just not something that we are as practiced working with. So here is very specifically, I'm going to really carefully try to just describe exactly how this process works. If you are struggling with beginning this process, this is the part of the lesson that you want to watch over and over again. Okay, so if you have questions, of course you can email me, you can pop into the chat and we can talk about it. But if you're working on your own and I'm not available for whatever reason, then you want to come to this part of the lesson and re-listen to this, because this is going to be sort of step-by-step exactly how you're going to do these. The first rule is we're going to think of the three angles that we know how, the three primary angles that we know how to find the exact value of. So those three are pi by 6, which is 30 degrees, right? Pi by 4, this is what we talked about in degrees, but now we're doing it in radians, and pi by 3. Okay, so we have to know that those are the three that we're going to use. You're not using pi by 2, you're not using pi or 2 pi or 3 pi by 2. Can't use those. I'll talk more about that as we go, but you just can't. Okay, trust me, you can't. It won't work. So you have to use these three or multiples, some multiples, not all multiples of these three. Okay, but what we need to do, because all of these, the one of the keys to this, one of the things to be aware of is once we get into radians, we call these pi by 12 questions. Take a look at the other questions we're going to do. 5 pi by 12, 7 pi by 12, we'll do 19 pi by 12, we'll do 13 pi by 12, 11 pi by 12, we'll do a variety of different pi by 12s. That's what these questions are. They are pi by 12 questions. Okay, so whenever I'm talking about this after you've seen it, or with other teachers or whatever, we call these the pi by 12 questions, right? This is what we're learning how to do, is how to find exact value of pi by 12s. So everything will be in pi by 12s. So I want to take these three ratios and turn them into the pi by 12 equivalent. So this one's 2 pi by 12. This one's 3 pi by 12. And this one's 4 pi by 12. Okay? And right away, with just those three, I can solve this question. Okay? Because I could do 3 pi by 12 minus 2 pi by 12 would give me 1 pi by 12, or 4 pi by 12 minus 3 pi by 12 will give me 1 pi by 12. So I can solve this question with just those three. But there are other questions that you can't. And so we need more than just those three to solve some other questions. Okay? Like 19 pi by 12, I can't make that work with just those three as an example. So what you can do is you can take multiples of each of these. So I've got 4 pi by 12, 6 pi by 12. If I'm just multiplying this out, 8 pi by 12, 10 pi by 12, 12 pi by 12, and so on, 14 pi by 12. And I'm not going to write them all out because we could keep going forever. Not very often you would have to go past 14, but it is possible. There is some choice. There are some questions where you have big numbers and you would have some choices of what to do. So it's possible to go past 14. You may not have to, but you may. But there's the idea, right? 2, 4, 6, 8, 10, 12. And it's just multiples of 2 pi by 12. So multiples of this are 6 pi by 12. Hopefully you're getting the idea here, because again, you can memorize this list, but it's better to understand where it comes from and just be able to kind of build it as you go. 12 pi by 12, 15 pi by 12, 18 pi by 12, 21 pi by 12. Again, I don't remember using 21 pi by 12, and the next one would be 24 pi by 12 very often, but you never know. Okay, and then 8 pi by 12, 12 pi by 12, 16 pi by 12, 20 pi by 12, and again, so on and so on. Now, there's our list, and it does go on, but there's our list. But there are some values here that will not work, and there are some that we've doubled up, and so we just want to point that out. So one of the questions I often get from students is, how do I know what this list is? And I mean, you know, the short answer to that is, well, you memorize it. But like I say, you can also just understand where, like, how to develop it and just make it yourself without necessarily memorizing it. But what you also have to understand is which ones are no good. And there isn't an easier explanation to that or an easier answer to that than you just have to kind of know it and get used to doing it and remember some of the rules. So one of the things is you cannot use any multiple of pi by 2. So no multiples of 90 degrees, no multiples of pi by 2. They will not work for pi by 12 questions. If you wonder why, then I would say, why don't you try it and you'll see what happens. Okay, it's not helpful, it doesn't work. So that takes 6 pi by 12 out. It takes 12 pi by 12 out. Whoops. And again, I've got 12 pi by 12 and 6 pi by 12 in some of my other areas here. So that one's gone, that one's gone. 24 pi by 12. 18 pi by 12 is 3 pi by 2. So that one's no good. So we eliminate those ones. They will not help. You cannot use those. What I also notice is 4 pi by 12, when I see it there, is also here. So when you are going to, I suppose the best thing to think about here is when you are going to actually answer your question and do the work, you have to, your fraction has to be in lowest terms. It has to be fully simplified. And when I fully simplify, even though 4 pi by 12 is a multiple of pi by 6, when I simplify it, it's actually pi by 3. I wouldn't simplify it to 2 pi by 6 and use that in a question. I would simplify it to pi by 3. So for some students, it might be easiest to just look at all the multiples of pi by 6 and pi by 4. And those are the ones that you can use. All of the multiples of pi by 3 are also in pi by 6. I hope this makes sense. Okay. So, you know, you could just think of multiples of pi by 6 and pi by 4, but you have to know which ones end up actually being pi by 3s. So both 4 pi by 12 and 8 pi by 12 are actually, when you solve the question, you're actually going to use them as a pi by 3 angle. So in that case, I would kind of maybe cross this off and cross this off, because they're 4 pi by 12 and 8 pi by 12 are actually multiples of pi by 3. But again, there's no rule about, like, you don't have to write out this list. You don't have to show this work. So if you're just thinking about which values you're allowed to use, you could just think to yourself, 2, 4, 6, 8, 10, 12, except 6 and 12 are no good, right? But you could just think the multiples of 2 and the multiples of 3 are the ones that you can use. And then we're going to write it out. And then when we reduce the fractions, you just have to make sure you're reducing them to the correct fraction. If that doesn't make full sense, again, I would strongly encourage you to come back and watch that explanation from the beginning after you've tried a few and after we've done a couple of together. So I'm going to go and do a few of these examples. And then I would say come back and watch this again. This explanation started at about the 15-minute mark of this video. So you can keep that in mind. And if you want to, and after having done a couple and seen a couple, if you come back and watch that part, I think, you know, it'll help more and it'll make more sense, right? Or go ahead and ask and we'll talk about it. So all of that being said, our first step is to take our list of fractions that we have here in radians, radian measures, and find two that add or subtract to what we're trying to find. So we're trying to find 1 pi by 12. So 3 minus 2 or 4 minus 3, both of them work. Let's do 4 minus 3 this time. So that's cos of 4 pi by 12 minus 3 pi by 12. And 4 pi by 12 minus 3 pi by 12 is 1 pi by 12. Okay, so again, if you're turning this into a step-by-step process, that's the first step. You take this list, and you have to know how to develop the list or memorize it. And you just figure out from that list two values that add or subtract to what you're trying to find. So 4 minus 3 is 1. And I ignore the pi's, I ignore the 12s. I just think about the numerator, the number on top. 4 minus 3 is 1. So 4 pi by 12 minus 3 pi by 12 is 1 pi by 12. Then you reduce them. Step 2, reduce. 4 pi by 12 reduces to pi by 3. 3 pi by 12 reduces to pi by 4. Then you use the formula. Hopefully this is looking already familiar to the first one that we did in degrees. Remember, the formula is cos, cos, sine, sine. So cos pi by 3, cos pi by 4. But the sign is different. So plus sine pi by 3, sine pi by 4. Then we evaluate each of them. Cos of pi by 3 is 1/2. Again, you'd be using the special triangles. I'm not going to go over all of that at this point in the course. We're supposed to just kind of know how to do that, so I'm not reteaching it. So I hope it's okay. I hope you're okay with me kind of rushing through that part. Sine of pi by 3 is root 3 over 2. Sine of pi by 4 is 1 over root 2. Then simplify. So 1 times 1 is 1. Root 3 times 1 is root 3 over 2 root 2. And in the first example, I sort of did that in 2 steps, right? But after you've done this a bunch of times, the steps get very familiar and very repetitive. And so, you don't have to do that in 2 steps. You can definitely do it in 1 step. That being said, I would suggest showing all 5 of these steps, in particular when you're starting out and practicing, right? On a test, you could skip this step and just go straight to the next step if you really want, but only if you're sure that what you're doing is correct. But you definitely need to show at least that, and that, okay? So minimum 4 steps, but showing this step as well is very helpful, and it really helps you break down the process of how you are finding what those numbers are, right? And then you reduce them and then you move on. So even if I thought of, this is what I was saying before, even if I thought of 4 pi by 12 as in that row, it reduces to pi by 3. I'm not going to evaluate it as a 2 pi by 6 or something weird like that. Okay, and that's how you do it. And every question is going to be exactly the same. It's going to be those 5 steps. I come up with 2 fractions from our list, okay, that will add or subtract to what we're given in the question. Then I reduce them. Then I use the formula to expand it. Then I evaluate each of the 4 ratios. Then I simplify. And that's how every one of these pi by 12 questions will work. So you need to know the formula so that you know how to expand it. You need to understand the basic idea of what we're doing here, that we're turning a pi by 12 into a sum or difference of other angles that we already know, right? Which are those 3. Those are the 3 that we know how to find given the special triangles. As I said, we do know how to find other exact value of other angles like 0 and pi by 2 and pi and 3 pi by 2 and 2 pi, but those don't help in this situation, so we can't use those. So we just have to use these multiples. And then you need to know this list, right? You need to understand how to develop that list and why those are the ones that we can use. And you need to know that 10 pi by 12 is fair game, 15 pi by 12 is fair game, 20 pi by 12. Like, you need to just know that those are your options. And once you have that, every single one of these questions is step by step, almost identical. And as I said, the answers work out to almost always being the same. Take a look at these 2. They're the same, right? Root 3 plus 1 and 1 plus root 3 is actually the same. Well, these were actually the same question. Cos of 15, pi by 12 is 15. They actually were the same question. In this case, I did 45 minus 30. In this case, I did 60 minus 45, so I did them a little bit differently, and that's why the order was different, 1 plus root 3 and root 3 plus 1, but again, one's not more right than the other. The order of the numerator absolutely doesn't matter, but you can see that they're the same, and you really can see that the steps were very similar. And like I say, once you practice these a whole bunch of times, you start to get that you start to recognize how they play out every time, and you'll build that confidence, and you know it ends up working out quite nicely. Like, it ends up being a nice process to follow. Okay, so we'll do 2 more coses, and then we're going to flip over and do a couple of sines. Really, there's no difference between cos and sine. The formula is a bit different, but everything else is the same, so that's why we're sort of shoving these 2 lessons together. So first step, looking for 2 numbers that add to 7. So, you know, you might think, well, 6 and 1 add to 7, but 6 and 1 are not angles in our list, right? 6 and 1 are not values in our list, so I can't use 6 and 1. What about 5 and 2? No, 5 and... Is 5 in our list anywhere? 5 is not in our list, right? So 5 pi by 12 is not going to help. It's no good, okay? So what can we do? I can do 3 plus 4. That would work. 3 plus 4 is 7. 9 minus 2 is 7. 10 minus 3 is 7. There are all kinds of different options. If you can use quadrant 1 angles, why not? Makes it a little bit easier. But whatever you come up with, you know, it's not that much of a difference. And so, you know, whatever you come up with, go for it. And you'll get the same answer. You'll get the correct answer no matter which you choose. But, you know, you may choose different ones. In this case, almost everybody would probably go with 3 plus 4. But in other cases, there are going to be options and people will choose differently. So 3 plus 4. And I like to show this step. Cos of 3 pi by 12 plus 4 pi by 12. Again, this is the one that you don't have to show necessarily, but especially when you're starting out, or if you like to sort of take things step by step and not rush through things because that's what causes people to make mistakes, then that's a really good idea to show that step. And then we're reducing them. So 3 pi by 12 reduces to pi by 4. 4 pi by 12 reduces to pi by 3. Then I use the formula, and you'll notice that this is almost identical step by step to the last question, and you'll see what I mean. Remember, the formula is cos, cosine, sine, but the sign changes, so it was adding. So I subtract in the formula, sine pi by 4, sine pi by 3. Next step, evaluate each of them. Pi by 4s are always 1 over root 2, sorry. Cos of pi by 3 is 1/2. Sine pi by 4, again, 1 over root 2. Sine pi by 3 is root 3 over 2. And that works out to 1 minus root 3 over 2 root 2. So, see how similar that is? It's not exactly the same as the other ones. This was 1 plus root 3. This one's 1 minus root 3, but the answers are always over 2 root 2. Like, there's just a lot of repetition in these questions, and I always say when you do the work and you notice that, it's great because you're not going to get on to the test and make a mistake. Like, you're gonna know what your answer should work out to and should look like, and be able to catch those kinds of mistakes. Okay, hopefully that makes sense. We'll do one more cosine one, then we're going to flip over to the sine. And we didn't talk about negative angles in this year in this course. But in this case, we don't have to evaluate this as a negative angle. We just have to come up with, and we're going to come up with a difference of 2 angles that gives us -5, right? So again, we're looking at the same list. And you look at any 2 of these that add or subtract. So it's going to be subtract because it's negative. That subtract to -5. So I could do 9 minus 14. That would give me -5. I could do 3 minus 8. That would give me -5. Like, there's 4 minus 9. There's lots of options. I'm going to do 3 minus 8. But you can look at all these different options for anything that is going to subtract to -5. Again, like I said, if you can use quadrant 1 angles, it will make the work a little bit easier. You can't always, absolutely, but if you can use at least one quadrant 1 angle, that might help. So like I said, I'm going to do cos of 3 pi by 12 minus 8 pi by 12. But you could do something different. So if you want to try one of these on your own, now's a good time. You've seen all the steps. Often at this point, students are ready to go ahead and try one on their own. So you could do something different. You could try 4 minus 9 and see how you'll get the same answer. It might look a little bit different, but you'll get the exact same answer in the end. Not a bad idea if you want to give that a try. Or even just when you're doing your homework, if you pick two different angles from what the homework solutions chose, it's good to see that, okay, it still worked out the same, and so it might look a little bit different. It might look like this or look like that, but it's the same answer. It's a good thing to see, right? Okay, so first step, come up with two numbers, in this case 3 and 8. 3 minus 8 is -5, so that's going to work. Reduce. 8 pi by 12 reduces 2 pi by 3. One mistake that students make is they always reduce to a quadrant 1 angle, so they reduce that to pi by 3. Absolutely no, you don't do that. You're just literally reducing the fraction. 8 pi by 12 reduces to 2 pi by 3, so 2 pi by 3, we have to keep it that way. We can't just change that into 1 pi by 3. Okay, that will be a big mistake. Then use the formula. And then evaluate these. And I need it to be 2 pi by 3 because the quadrant that it's in makes a difference, right? That's going to change the answer. So if you just change it to pi by 3, all of a sudden you're changing the answer. So this is a quadrant 2 angle, and cosine is negative in quadrant 2, so that's -1/2. And so you see what I mean by you do still have to think about quadrants in the cast rule, but if you memorize the ratios here, and after you've done all this work, you will, even generally speaking, I think almost everybody does without even trying, because there's only so many options. So you need the cast rule to figure out whether it's positive or negative, but it always kind of, other than that, it always kind of works out the same. So 1 times -1 is -1 over 2 root 2, whoops, plus 1 times root 3 is root 3 over 2 root 2. And often, calculators, computer programs, that kind of thing, will write it this way because it's, I suppose, a little bit less writing. Is instead of -1 plus root 3, obviously both are correct. It would be fine to write it either way. You don't have to write it this way, but you would often see it done that way. In the solutions, you might see that, and there's no real reason except it's just kind of a habit, I suppose. Okay. So there you go. And again, comparing that to some of the other answers, or the other answers that we got, you really do notice how similar they are every single time. Exactly what the signs are is going to change a little bit, but otherwise, these questions always have very similar looking answers. Okay. And like I said, there's only so many options that you can get. So we're going to get different quadrants. So, it could be like this is a 2 pi by 3, but otherwise it's the same idea. So all you can really do is have cos of pi by 3, or cos of pi by 6, or sine pi by 3, or sine pi by 6. And many of you have probably already noticed this, or cos pi by 4 and sine pi by 4, because they're the same, and they're both equal to 1 over root 2. Sine of pi by 6 is 1/2. Sine of pi by 3 is root 3 over 2. Cos pi by 6 is root 3 over 2. Cos pi by 3 is 1/2. So that's it, right? You've got 6 options. And or even 4 if you sort of think about it that way, because these are always just 1 over root 2. Like there's really not that many. So you will memorize these, and then it's just a matter of determining if they're positive or negative, and doing the other steps, right, to get the proper sum or difference at the top. Okay, so we will do a couple of examples. We did a few with cosine. We'll do a couple with sine. Again, the steps are exactly the same. It's just the formula that's a little bit different. So here we go. We've got a sine of pi by 12. The last one we did, I believe, 4 pi by 3, or sorry, 4 pi by 12 minus 3 pi by 12. So how about we do this one as 3 pi by 12 minus 2 pi by 12. Right, so that's your first step, is to come up with, from that same list, come up with sum or difference that gives you the angle that's given in the question. Next step, reduce them. You'll also notice that every single time you're using a pi by 4 and either a pi by 6 or a pi by 3, that absolutely is true. That will happen. Okay, next step, you got to make sure you get the formula right. So sine, this is the one where the ratios flip. It goes sine cos, but the sign is the same. So it was subtracting, and I'm still subtracting, and then cos sine. Some teachers do this, like everybody does this a little bit differently. Some people do sine cos, and change the angles, and some people, like I do, sine cos, cosine. Doesn't matter, obviously, you're going to get the same answer in the end. But if you're looking at somebody else's solutions, or work from a student who's in another teacher's class and they show a slightly different version of this formula, that's why. It's not a big deal. Okay, and then evaluate. Again, these are all quadrant 1, so it's just really straightforward. And this one is root 3 minus 1 over 2 root 2. Okay, so you can see how similar this is to cosine, and that's why these two lessons fit together and make sense to do them together. It's the exact same 5 steps, exact same idea. The formula is a bit different, but that's all. Okay. At this point, I haven't sort of slowed down yet, so if you want to pause and try this one on your own, I think that's a great idea. And then when you've tried it, unpause and take a look and make sure that you've done it correctly. But I'm going to go ahead and do this next one. Again, you'll see there's some really cool concepts in the development of this equation, the sine equations. We look at some really neat ideas. This was something that unfortunately we don't have time to talk about, but it really does. Thinking about these things really adds to our understanding of trigonometry, I think, and just sort of exploring some of the relationships in here, but we just don't have time. So, you can take a look at that lesson if you want, or just take a look at the completed lesson, not the video, but just this version if you want, and sort of think about it a little bit would be great. But otherwise, we're just going to do these 2 examples for sine, and then we'll be done. So pause if you like and try this one. Okay, and now I'm going to go ahead and I'm going to try it. And again, we're looking at our list. I'll jump back to where we had the list. And what I'm looking for is any 2 fractions, radian measures that are in this list that add or subtract, in this case, to 11, right? So that's what we're looking for. So you can't do 10 plus 1. 1 is not in this list. 1 will not work. And again, some people say, well, why? Well, we can talk about why, and if you really want to know, you can ask me, or I would encourage you to try it and you'll see what happens, and hopefully you can kind of figure out for yourself why it doesn't work. But it doesn't, right? So these are the only ones that you can use. You can keep going, but there's none other smaller ones that are missing from here. So we're looking for 2 that add or subtract to 11. And I'll give you a second to try to find a couple. So we could do 15 minus 4, 14 minus 3, 3 plus 8, right? and or I'll do 9 plus 2. Okay, and if you want to try a different one, that's a great idea. You can try 3 plus 8. I'll do 9 plus 2. We can compare our answers. Next step is to simplify. Next step is to expand with the formula. Next step is to evaluate. So 3 pi by 4 is quadrant 2. Sine is positive in quadrant 2, so it's still positive 1 over root 2. Cos pi by 6 is 3 over root 2. Cosine is negative in quadrant 2. And then simplify. Okay, and we're done. And so if you did it with 8 and 3, you may have ended up with 1 plus root 3 over 2 root 2. But, you know, like I said before, those are the same. So no matter what, you will end up with the same answer, even if it's in a slightly different order or looks a little bit different. There are some cases where it's more common with tan, but where your answer may look a little bit different from the answer in the solutions, but they're still the same. It's more common in other areas, not so much for sine and cosine, but be aware of that. And so if you think you've done everything correct, then as I explained before, you can use your calculator to check your answer and make sure that you've done it correctly. And you could always compare your answer to the one in the solutions again by subtracting them. As long as you type them into your calculator properly, you can tell if two expressions are the same, right? So that's that. Hopefully that makes sense to everybody. Hopefully you can see how step-by-step a process this is. It is the pi by 12 questions. It's important to note that in the homework there are a couple of questions that we didn't do an example of, but they're really just formula questions. So I think everybody should be okay figuring those out. If not, you can ask about them. But these are the more of the focus on the kinds of questions that we're looking at is solving these pi by 12 questions. Okay, and so that's that. Remember, it was the 15-minute mark where I explained where the list of values came from. Where did it go again? Here it is. Where I started actually talking about how to do it in radians. It was around the 15-minute mark. So if you want to go back and watch that again, listen to that part. That after we've now done a bunch of these, and after you try a bunch, I think that's a great idea. But do be aware that these questions are very repetitive, very similar every single time you do it. And so after you've practiced a bunch of times and you start to get comfortable with that process, you should start to have that confidence in expecting how it's going to play out and how each step looks. And it ends up being a nice process like that you can have a lot of success with. Okay, good luck.